Applications of quadratic equations. Example 1. A rectangle has dimensions 3x plus 5 and 2x minus 2. Okay, if the area of the rectangle is 760 centimeters squared, find the dimensions of the rectangle. Okay, so I'm going to go ahead and just draw a little diagram. Okay, so we have 3x plus 5 and we have 2x minus 2. Okay, and it gives us the area. So if we're actually writing like area equals length times width, we would write like 760 equals, well, what's the length? 3x plus 5. And then what's the width? 2x minus 2. And we're just trying to find the dimensions. So we're trying to solve for x. So let's go ahead and expand this. So we'll leave the 760 on this side. So 3x times 2x is 6x squared. 3x times negative 2 is negative 6x. 5 times 2 is 10x. 5 negative 2 is negative 10. And let's bring over that 760. It becomes negative 760. Okay, we're going to collect negative 6x plus 10x. So I get 4x. And all we're doing here is simplifying. And those two give me negative 770. Okay, so here is the equation of the area. So length times width equals 760. All we did is expand, rearranged, and set it equal to 0. So now in order to solve for x, we have to factor. Okay, so I can see that we can divide each of these by 2. So let's just common factor out the 2. We're left with 3x squared plus 2x minus 385. Okay, so the coefficient of x is 3, so we're going to use decomposition. So what number multiplies to a negative 1155 and adds to 2? Okay, so my little trick with this, we need two numbers that are very, very similar because the difference between them is going to be 2. So what I usually do is I root the number. So, and when I root it, I get 33.9852, something really ugly. So what I'm actually going to do is I'm going to start, since it's such a big number, I'm going to start with 1155, and I'm going to divide by 33. And I actually think I got it on the first try. I think I got 33 and 35. And because the middle term is positive, I would put the negative on that 33. Okay, so let's break down this 2x into negative 33x plus 35x. Okay, and then we're going to factor by grouping. So let's group the first two terms. And remember, this 2, just keep bringing it down. The first two terms, I'm going to factor out 3x. And I get x minus 11. And the second two terms, let's see if I can factor out the full 35. 35. Yeah, I'm going to factor out that full 35, and I'm going to get x minus 11. Okay, so I get 0 equals 2. And out of those two, the x minus 11 is the common factor, and I'm left with 3x plus 35. So if we take a look at those factors, I'm just going to rewrite it up here. What we're going to do is we're going to branch this factor off. Remember, we don't have to branch off the 2 because it doesn't have an x attached to it. So x minus 11 equals 0. We get x equals 11. And then we get 3x plus 35 equals 0. We bring that over. I get 3x equals negative 35. And then I divide out. So I get negative, I think it doesn't, yeah, it's not a nice decimal. Let's just leave it as negative 35 over 3. Okay, so if we think in the context of this question, we're thinking about dimensions, it makes more sense to have the dimensions as 11. If we subbed in the negative 35 over 3, we're going to get negative dimensions, which doesn't make sense. So the actual question is sorry, the actual question is find the dimensions of the rectangle. So let's go ahead and say, okay, the first dimension is 3x plus 5. And if we sub in 11, we get 33 plus 5, I get 38 centimeters. Okay, and we can decipher that because 760 centimeters squared. And we get 11 minus 2, so I get 22 minus 2, I get 20 centimeters. Okay, so therefore, dimensions are 38 by 20. Okay, and you can double check what's 38 times 20. Well, it's 760, so that's a good check. Okay, example 2. A stone thrown off of a cliff into a river is modeled by the quadratic relation of this. Okay, so x represents the distance. So sometimes it's time, but in this case it's distance. Okay, traveled in meters horizontally, and y represents the height. We can finish writing that. Okay, above the surface of the river. So this 0 would be like the river. So how tall is the cliff? We want to know essentially what's going to happen here is we have some stone and it's thrown off and then it splashes into the water. We want to know how high is the cliff. In other words, it's asking for the y-intercept. What we do is we sub in x equals 0. Well, this is convenient because we already know from studying this equation, if we sub in 0, these two terms are going to go to 0, so the height is 84. Height of cliff is 84 meters. Okay, at what distance is the stone when the height reaches 60 meters? Well, when we have height reaches 60 meters, we would sub in the 60 for the y. And it says at what distance, so we're going to solve for x. So all we're doing here is subbing in the 60, bringing the 60 over, so I get 0 equals negative x squared plus 5x, and then 84 minus 60, I get 24. And what we want to do is we want to solve for x now, so we're going to factor. Factor out this negative 1. And now what two numbers multiply to 24 and add to negative 5? 124, 212, 38. 38 works. And the negative is going to go on the 8. So x plus 3, x minus 8. And sorry, we're going to go up here. We're going to set x plus 3 equal to 0, and then x minus 8 equal to 0. Oh, I don't have to correct that. So we get x equals negative 3, and then x equals 8. So it wants to know at what distance does it reach? Well, we can't go back in time, so the x equals negative 3. Sorry, not back in time. We can't go back in distance. Like this part of the graph doesn't exist. So this is called inadmissible. Okay, so we can say, therefore, at 8 meters, the stone is 60 meters high. Okay, and then C. How far does the stone travel horizontally before it hits the water? So when it hits the water, we're looking for this number because we're going from 0 to this number. But we're going to go back to the original equation. Okay, not the equation with the 60. So let's go ahead and factor out the negative 1, and we're left with x squared minus 5x minus 84. So what two numbers multiply to 84 and add to 5, to negative 5? So we get 184, 242, 6 and 14. I think we're getting closer. Let's try 7 and 12. And the negative, since it's on the -5, is going to be on the bigger number, -12. So I get y equals negative x plus 7, x minus 12. And therefore, when you branch off, x is going to equal -7, and then x is going to equal 12. Okay, so when we look at these, -7, oh, in green, -7 is inadmissible. So therefore, at 12 meters, I'll just say the stone hits the water. It hits water. Really small. Okay, example 3. A picture has the dimensions of 15 by 10. So we're going to go ahead and we are going to just draw like a rectangular picture. This is 15 by 10. Let's put the 15 inside. Okay, if a mat uniform width is fitted around the picture and the new area is 336, so let's put a mat border is just like usually it's like white or black and it just makes your picture pop. Okay, and it's uniform width. So what that means is that these two widths are going to be the same. So instead of the width going to be 10, it's going to be 10 plus whatever this number is, and then whatever this number is, right? But they're the same number. So this is going to be 10 plus 2x. Okay, and then the width of the mat on the other side is going to be the same as well. Again, x and x. So 15 plus 2x. Okay, so the new area is going to be 336. Find the width of the mat. So what we're going to do is find x. Okay, and then just simply like let x represent the width of the mat. Okay, so if we want to do area equals length times width, we can just simply do 10 plus 2x times 15 plus 2x, and that's going to equal the new 336. Okay, so we can just go ahead, just like the last one, we can go ahead and expand these, and then we'll bring over the 336. Okay, so 150 plus 20x plus 30x plus 4x squared. And then that 336 we're going to bring over, and it's going to become negative 336. So every question that we work with, we want to put in standard form, like the standard form of the quadratic relation. So let's put the 4x squared first. Now let's collect the middle terms. So we get 50x, and then we have 150 minus 336. And I get negative 186. Okay, and in order to factor, we need all of the terms on one side and this equation to equal 0. So now we can go ahead and factor. Okay, to get these terms a little bit smaller, I'm going to common factor out a 2. So we're left with 2x squared plus 25x minus, and then 186 divided by 2 is 93. So what two numbers multiply to, it's not 93, but it's 186, and add to 25? Okay, so let's take the 186. It divides by 2, so we get the factors of 1 and 186, 2 and 93, 3 and 62. 4, 5. We get 6 and 31. Yeah, 6 and 31. That looks good. Okay, and then the negative is going to go on the 6 since we have positive 25 that it has to add to. So we get 2, and we have 2x squared minus 6x plus 31x minus 93 equals 0. Okay, so let's factor out a 2, and then we'll factor out a 31. So we have 2, we'll factor out a 2x. We have x minus 3, and then let's factor out a positive 31. We're left with x minus 3. And sorry to do this backwards, but our full factor is 2x plus 31, x minus 3 equals 0. So to find the actual width of the mat, we're going to solve for x. Remember, 2 doesn't have an x in it, so we don't have to actually solve for that. And now 2x plus 31 equals 0. We bring over the 31, and we divide out the 2. This is negative. This is not going to be the width of the mat. But bring over the negative 3, we get x equals 3. X equals 3 is going to be the width of the mat. Therefore, x equals 3 centimeters is the width of the mat. Okay, the sum of the squares of two consecutive odd numbers is 202. Okay, so first of all, sum is plus. Squares is going to be something squared plus something squared. And then consecutive odd numbers. Okay, so we're going to kind of go let x represent the first number. Okay, so if the first one is x, then the second one is x plus 2. Because to get from for example, from 1 to 3, we have to add 2. From 3 to 5, we have to add 2. So every time we add 2 to consecutive numbers, we get another, like say, if we started an odd number, we get another odd number. Okay, is an equal sign and then 202. Now the question asks, what are the values of the two numbers include let statements? So I got a let statement already. Now we have to expand this x plus 2. So we need x plus 2, x plus 2. Okay, so let's go ahead and FOIL it. And we get x squared plus 2x plus 2x plus 4 equals 202. Now let's collect like terms. So we have 2x squared, and we have 4x, and we bring over this 202 and we get negative 202. So we get minus 196. Okay, let's go ahead and factor out, we have to factor this because we have to solve for x. So we can go ahead and common factor out a 2. So we have x squared plus 2x minus, I guess 98. Yeah, 98 equals 0. Okay, and now what two numbers multiply to negative 98 and add to 2? The factors are, let's do that shortcut. Well, what's the root of, like, say 100? It's 10. So this number is going to be around 10. Let's see if we can go 98 divided by 9, 8, 7. 7 and 14. I know why that wasn't working. I'm just going to change one number. This is 198. So we get 99. So what two numbers multiply to 99? That's much better. And that's why we can get 9 and 11. And since they have to add to 2, the negative sign is going to be on the 9. So let's go x minus 9, x plus 11. This is how you fully factor this. Okay, so we wrote an equation, we expanded it to here, fully expanded, equaling to 0. Now we can factor it, and now we can solve. So I'm not going to do the full equations to solve and bring it over. but we get x equals 9 and x equals 11. Okay, so therefore, the two numbers are x equals 9 and x equals, you get negative 11. Okay, so these aren't consecutive odd numbers. What we actually have to do is we are going to plug in x equals 9. So the first number is x and the second one's x plus 1. So if we subbed in here, x plus 2, 9 plus 2, we would get 11. So the two numbers, are x equals 9 and x equals 11. That's one combination. Now, if we sub in x plus 2, we go negative 11 plus 2, we get x equals negative 9. So that's going to be the other combination of numbers. So there's actually two different answers here with two different x values, of course, for the two numbers. Example 5, a school dance charges $10 per ticket and has an average of 200 tickets sold. Okay, if they increase their ticket price by $1, they will sell 10 less tickets. Okay, so we're going to determine the ticket price that will maximize the revenue. Okay, maximize this asks us to find the vertex. Okay, so let's start with that and then we'll keep going. So what we want to do first is we want to find an equation. So I give you the setup of this equation. We're going to have revenue equals, and we're going to put the number of tickets sold all in one bracket. So tickets sold would be 200. And then every time they increase their ticket price, they're going to sell 10 less. So we're going to have actually 200 minus 10x. Okay, and we're going to let x represent the number of price increases. Okay, and then the price is going to be, $10 a ticket plus $1 times the number of price increases. So this is our equation here. Okay, so this is beautiful because it's already factored. So let's go ahead and solve for x. Okay, so by solving for x, we're saying how many price increases are there? And because these don't have like nice numbers in them, I'm actually going to do this the long way. So I get negative 10x equals negative 200 divided by negative 10. I get x equals 20. And then I get x equals negative 10. So I'm going to take the positive one. I'm going to say there are 20 price increases. Let's go back. Sorry, there are either 20 or negative 10. So really, if we're looking at this on a graph, what we're going to be looking at is 20 here and then negative 10 here. So what we want to do is we want to find the axis of symmetry. So let's add these together and then let's average it out. Okay, so sorry, there are going to be 5 price increases in order to maximize revenue. Now let's actually sub in the 5 to the revenue. So we have 200 minus 10 times 5, and then 10 plus 5. So 200 minus 50 is going to give us 150, and then 10 times 5, or 10 plus 5 is going to give us 15. So when we actually multiply this, we get 2250. Okay, so A, determine the ticket price. Well, we know that this was number of tickets sold, and then this here was the price. So we already actually plugged it in, plugged like our new x, our maximal x, which is 5, into the price formula. So ticket price is $15. Number of tickets will be this 200 minus 50, so 150. And then C, determine the revenue. So the revenue is at $22.50. Okay, last example. Example 6, Sasha works at Botanical Gardens and is planning a new rectangular rose garden. Okay, so let's draw this nice rectangular rose garden. And the dimensions are going to be 20 by 30. Okay, she plans to build a walkway with uniform width. Okay, so X. We can say let X be the width of the walkway. It says all around her garden. Okay, so it's not on two adjacent sides. This one's all around her garden. Okay, so we've seen this before with the map on the picture. Okay, so here's a little bit like something a little bit different. So this gives us constraint. Okay, our constraint is that her budget's $6,000. Well, that doesn't give me anything because we're talking about meters squared. But she knows that it'll cost approximately 10 meters squared to construct the walkway, or $10, sorry, per meter squared. So if we divide those out, her constraint is that the area can only be 600 meters squared. That's the maximum area. And that's okay, we'll work with that. So our new width is going to be 20 plus 2x, and our new length is going to be 30 plus 2x. Okay, so it's going to be similar to that first question that we did here. The area equals length times width. So 600 equals 20 plus 2x times 30 plus 2x. Okay, so here's our equation. Let's go ahead. Let's expand that out. Actually, going back, the budget just for the walkway is 600. So this is actually a little bit different. So this here is the area of the entire area. We actually have to subtract the area of the middle, which is 30 times 20. And the reason why we have to subtract the area of the middle is because we're only talking about the budget of $6,000 just for the walkway. So she doesn't have to redo the garden. Okay, and we can see that here, construct the walkway. So yeah, we have to subtract the middle area out of that. So now we have the entire area minus the area of the area of the middle, which is the garden. And this gives us, like, what's left over is the area of the walkway. So now we expand. 20 times 30 is 600. 20 times 2x is 40x. 2x times 30, 60x. 2x times 2x, 4x squared, minus 600. Okay, so let's bring this 600 over. We get negative 600 again. And now let's simplify and put in order. So we put the 4x squared first. We put plus 100x. 600 minus 600 go away, and we're left with negative 600. Okay, now that we have this in standard form equals 0, let's go ahead and factor. So we'll common factor out of 4, which gives us x squared plus 25x minus 150. So now what two numbers multiply to 150 and add to 25? 1 and 150, 2 and 75, 3 and 50, 5 and 30. Yeah, 5 and 30 work. And we're going to put the negative on the smaller number. Okay, so let's go ahead and factor that. We get x minus 5, x plus 30. So then our x is equal 5, and our other x equals negative 30. Okay, negative 30 is going to be inadmissible. It's not going to make sense because the one length is only 20 and the other one's 30. So that doesn't make sense. So our answer, our width is going to be x equals 5. So therefore, the width can be x equals 5.